Today, we'll be covering wireless network setup and configuration. And so we'll be focusing mostly today on wireless. The last time out, we discussed LAN, which is local area network. And we did set up a local area network between two systems on the network, a Windows 10 PC and a Windows 7 PC. So I want to also mention that all the possibilities, all the things we did in the last class, like file sharing, being able to do remote connection, connecting from one PC to the other, all of those things can still work on a Wi-Fi, on a WLAN network. So the only difference being that the last time out, we used network cables to connect the PCs to a switch, but today we will not be using a switch. Rather, we'll be using a wireless access point. So we'll be seeing how to connect to a Wi-Fi router that we have at home that normally give our home internet access. So that's what today's class will be focusing on. And instead of just jumping into the class and starting to set up the Wi-Fi device, we want to take a look at some few theory here. So a WLAN simply stands for wireless local area network. It's basically a computer network. In this computer network, it makes use of RF, and RF stands for radio frequency. So what is radio frequency? Radio frequency is basically an alternating current signal. This signal produced by a radio device or a Wi-Fi device is used to conduct Wi-Fi signals through a copper wire into an antenna, which the antenna goes ahead to push those signals into air, and they are called radio wave or radio frequency signals. So basically, we have a Wi-Fi router here. Now, this Wi-Fi router could have an antenna, but it could also have a Wi-Fi router that doesn't have external antenna. So it means the antenna will be built into the device. Whichever the case, they perform the same function. And so we've got a mobile device, which could be a mobile phone. We've also got a laptop here and probably a Wi-Fi printer, so could print out some copies of our document. And the idea here is that none of these devices, mobile phone, laptops, printers, will be using a network cable to connect to the Wi-Fi router. So this is a Wi-Fi device. So the way they symbolize RF, which is radio frequency, is like this. Okay, so this symbolizes that we are using wireless means, which is also referred to as radio frequency signals, to connect to this Wi-Fi device. So whether this Wi-Fi device has a built-in antenna or it has an external antenna, the function of the antenna is to broadcast the wireless signal so that the wireless devices will be able to see the Wi-Fi network and attempt to connect to them. And so when these wireless devices, like our mobile phones, our laptops, our wireless printers, see the broadcast coming out from the Wi-Fi device, they are going to try to connect to that Wi-Fi device wirelessly, where the Wi-Fi device is going to request for credentials, which is password. And then once the wireless devices here are able to provide those passwords, they will be allowed in return to connect to the Wi-Fi device. And so all of this communication passing through wireless medium is made possible by something called radio frequency. So in a WLAN network, all the devices that are connecting to the network are doing so wirelessly, and they are relying heavily on a technology known as RF or radio frequency in order to communicate to other wireless devices on the network. So this mobile phone should be able to send some files to this laptop. This laptop should be able to forward some documents to the printer, and all of this communication will be done wirelessly through the Wi-Fi device using radio frequency technology. And that's basically what a WLAN network is. And in a WLAN, we also have regulatory bodies, that is, bodies that make things happen, that regulate the entire wireless industry in terms of wireless equipment, the frequency bands that this equipment should operate on, and making sure that this equipment meets the industry standard in terms of compliance. And so the first body we want to look at here is the ITU. The ITU is the International Telecommunication Union. So the ITU-R, which is basically the R here, is radio communication sector. So we have the International Telecommunication Union, radio communication sector, and this body actually developed radio frequency bands. Okay, so we have different frequency bands available for wireless communication. So even in telecommunication network, the ISPs, they all make use of frequency bands in order to transmit and also receive RF signals. So there are a couple of frequency bands. So we have the likes of 900 megahertz frequency band. We have the likes of 1800 megahertz frequency band. We have 2600 megahertz frequency band. Okay, so all of these frequency bands are mostly used in telecommunication. So the likes of 2G system, the likes of 3G system, the likes of 4G, and then now we have 5G systems operating some of these frequency bands. So for us to be able to make call or send SMS, our phones will be making use of these bands to connect to a telecommunication network. Well, out of these frequency bands, there are specific ones that are reserved for Wi-Fi communication. So you remember when we did IP addressing in the class, we also mentioned that this IP addressing has private as well as public address. So the private are used in private communication. So if we have like 200 devices in our network and we have connected these 200 devices together in order for them to reach each other within the private network without having to pass through the internet, the IP addresses we'll be using to set up that kind of network is called private addresses. But there are other addresses that are called public addresses, which are the ones that allow those 200 devices we have on the network to communicate over the internet. Those are called public addresses, right? So public, not private. The private ones are the ones we use within the private network, while the public addresses are the ones we use within the internet or the public network. Same analogy applies to frequency bands. So these frequency bands are divided into two. We know that the ITU came up with the frequency bands, while the FCC, which is Federal Communication Commission in the United States, will be the one to look at these frequency bands created by the ITU and say, you know what, specific frequency bands should be used for internal communication, and specific frequency bands should be used for external communication, just as we have private addresses for private communication and public IP addresses for communicating on the internet. So we have licensed frequency bands as well as unlicensed frequency bands. So who should use licensed frequency bands and who should use unlicensed frequency bands? Well, for the licensed frequency bands is used by the likes of telcos, which is telecommunication companies. Think of Comcast, Verizon, AT&T, etc. These guys will have to get licensed before they can use certain frequency bands in their telecommunication network. So these licenses are granted to these telcos by the government of the particular country that the telcos are operating in. So we have the telecommunication companies, we have the internet service providers. These guys make use of licensed frequency bands, and the government will have to grant them the license before they're allowed to use specific frequency bands within that country. But unlicensed bands are used in private networks, aka Wi-Fi. Okay, so in a Wi-Fi network, we don't necessarily need to go meet government to give us license before we can now be able to set up a Wi-Fi. So basically, we just need to buy a Wi-Fi device and just power it on in our homes, and then boom, every device we have at home should be able to connect to that Wi-Fi network. No need for getting license from the government to set up those kind of networks. And that's why unlicensed band is reserved for setting up networks like Wi-Fi, or you may also want to call it WLAN, wireless local area network. And specific frequency bands that are made to be used for free without having to pay a dime to government to give us a license for those bands are 2.4 gigahertz band and 5 gigahertz band. So 2.4 gigahertz band and 5 gigahertz are classified as what? Unlicensed frequency bands, which means that we don't need to meet the government to give us a license before we can use equipment that operate in these frequency bands. So all the devices that we have for wireless local area network, including the router you have in your home, that router, the manufacturers of that router, that Wi-Fi router, must have complied with either 2.4 gigahertz or 5 gigahertz. So the equipment that we are purchasing for Wi-Fi should come already supporting either this 2.4 or 5. Now, if I have a Wi-Fi equipment that's operating in 2.4 gigahertz, it simply means that that equipment can travel longer distances. If I have Wi-Fi equipment or a Wi-Fi router that's operating 5 gigahertz, it means that that device can travel at a higher speed compared to the speed of 2.4 gigahertz equipment, but at a shorter distance. So the speed of Wi-Fi equipment operating in 2.4 gigahertz is slower. That has a slower speed, but longer distance. Wi-Fi equipment operating in 5 gigahertz has higher speed and shorter distance. So the higher the speed, the shorter the distance in terms of 5 gigahertz equipment. The Longer the distance, the slower the speed in terms of 2.4 gigahertz Wi-Fi equipment. Also, when we are buying Wi-Fi routers, we want to know which frequency band they are operating on, depending on how far we want the signal of the wireless device to go. The IEEE, Institute of Electrical and Electronics Engineer, Institute of Electrical and Electronics Engineer, and this actually is one of those non-profit organizations that helps us in creating and maintaining standards. So the IEEE will basically ensure that the rules made by the FCC vendors that make Wi-Fi equipment are compliant with those FCC rules. And so this Institute of Electrical and Electronics Engineer has so many working groups. Working groups basically are a group of engineers that are assigned a specific area of technology to develop. It was created in the year 1980 in the month of February. Okay, and so 1980 February, that's what we actually have as 802, right? So whenever you hear IEEE or you see IEEE, they are always associated with 802. So the 80 is the year 1980, while the 2 is the month of February 1980. So they use that as a code because I did say that IEEE has a lot of working groups, which once again are a number of engineers that are grouped together and assign them a specific area of technology to develop. So there is IEEE 802.1, there is IEEE 802.2, there is IEEE 802.3. Now, what is of importance here is that 802.3 handles LAN. So the guys within that working group are assigned the task of developing local area network technologies. Technologies used within the LAN include Ethernet. We have several cables that we can use within the local area network in terms of Cat5, Cat5e, Cat6, Cat7, etc. And these are Ethernet cables because those cables are made with Ethernet technology, including our NICs, our network interface cards, which is the LAN adapter we have on our PCs. So for local area network technology, the IEEE working group that is saddled with the responsibility of developing that area is called IEEE 802.3. Well, this class is not focusing on LAN, rather it's focusing on Wi-Fi or WLAN, which is wireless local area network. And so we want to focus on a working group that is specifically after the wireless standards, and that is IEEE 802.11 working group. So 802.11 is the one responsible for developing wireless technologies, including infrared, Bluetooth, Wi-Fi, etc. So the IEEE 802.11 creates standards that are used in wireless technology. So let's look at this IEEE in detail. They have different working standards within the Wi-Fi. So it's basically called Wi-Fi standards, or some documentation call it IEEE 802.11 lineup. So all the technologies we use in wireless networking today normally associated with 802.11. The reason being that 802.11 is the working group that is in charge of wireless technology. So let's go over to the next on the whiteboard and see several IEEE 802.11 lineups. And we'll be able to explain what is the differences we have in each of these lineups. So here we have the IEEE 802.11 lineups, IEEE 802.11a, we have IEEE 802.11b, there is also IEEE 802.11g, IEEE 802.11n, IEEE 802.11ac, and IEEE 802.11ax. All right. So we can actually check which of these do our PCs support. So if our PCs have Wi-Fi cards that enables the PC to detect and connect to a wireless network, today we are going to see which of these IEEE 802.11 lineup cards is installed in our PC. Okay, so that will be one of the takeaways, how to detect this in our system in this today's class. So IEEE 802.11a, that's where we want to start. So 802.11a operates in 5 gigahertz frequency, 5 gigahertz. So I'll probably be putting those things here. So IEEE 802.11a operates in which frequency band. So when we talk about frequency band, it operates in 5 gigahertz. We recall that on the wireless network, we are, especially Wi-Fi or WLAN, we are using unlicensed frequency band, which means that we don't need to get license from government of the day to run those equipments that are operating in unlicensed band. So this 802.11a has a speed of 54 megabits per second, 54 meg. And let's look at 802.11b. 802.11b can actually operate in 2.4 gigahertz. So it means that if we have a Wi-Fi router or a wireless access point that is operating in 2.4 gigahertz frequency band, the signal of that access point can go far compared to the signal of the one operating in 5 gigahertz, which is 802.11a. So we know that 2.4 travels longer distance, but 2.5 gigahertz has shorter distance, but at a higher speed. Look at the speed that we have in Wi-Fi equipment that operate in 802.11b. The speed is so poor, 11 megabits per second. Compare that to 11a, which is operating in 5 gigahertz. This is 54 meg. Now, 802.11g is the next. So 802.11g actually is operating also in 2.4 gigahertz in terms of frequency band, GHz. So the frequency band is 2.4 gigahertz. The speed is a little bit better than what we have in 802.11b standard. So the speed here is 54, which means that it has been upgraded to be at the same speed with what 802.11a can offer. The 802.11n operates, we call it dual band. Dual band is when a Wi-Fi equipment operates in both 2.4 and 5 gigahertz. So dual band equipment are from 802.11n and above. So in terms of frequency band, for 802.11n standard, we have both 2.4 and 5 gigahertz supported. Now, this is the kind of equipment I like to buy. So if I'm buying a Wi-Fi router, I would normally prefer that the router is operating in both 2.4 and 5 gigahertz. The reason being that the Wi-Fi device, the more I'm closer to the device will switch me to 5 gigahertz, which is a faster connection. But the moment I'm taking my laptop away from this device, maybe I'm coming down somewhere here to sit, or to sit in front of a TV and look at what is happening, listen to the news. The further I go out of this device, the more difficult it becomes for 5 gigahertz frequency band to still be giving me the signal. So it will get to a point where the device will switch me to 2.4, which means that the speed of my connection will drop because 2.4 gigahertz is not as fast as 5 gigahertz, but travels longer distance. So my speed is going to drop, but I will still be connected to the Wi-Fi, even though I'm far away now from the Wi-Fi router. But if this Wi-Fi router operates only in 5 gigahertz, it means that once I am far away from the coverage of 5 gigahertz, I will lose connectivity to the device. Okay, so that is the benefit of having two dual band equipments, meaning equipment that operates in both 2.4 and 5 gigahertz. So we have those dual band equipment from IEEE 802.11n devices. We have IEEE 802.11ac. 11ac operates both in 2.4 as well as in 5 gigahertz. So everything from 802.11n and upward always support dual band, which is 2.4 and 5. So from the documentation, the speed we have for the IEEE 802.11ac is actually up to 450 megabits per second. Compare that to the ones we have here. Basically, this guy can go 100 meg. That is 11n, 100 Mbps. So that's an upgrade compared to the earlier standards before the 11ac came out. And another term they call this 802.11ac is Wi-Fi 5. So is gigabit Wi-Fi or Wi-Fi 5. So this 450 Mbps is actually when the Wi-Fi device is operating in 2.4 gigahertz frequency band. But when it's operating in 5 gigahertz frequency band is over a gigabit per second. Okay, so we are looking at 1,300 Mbps, which is, we know that 1,000 Mbps is what? 1 gig. 1 gigabit. And that's why they call it Wi-Fi 5 or gigabit Wi-Fi. Now, let's look at the last one here we have on the whiteboard, the IEEE 802.11ax. It seems to be the latest in terms of these standards. So it also supports both 2.4 in terms of frequency band. It supports both 2.4 as well as 5 gigahertz frequency. Now, this standard is also referred to as Wi-Fi 6 or high efficiency WLAN. So this, when you hear Wi-Fi 6, they are talking about the IEEE standard 802.11ax. On theory, theoretically, it can go up to 10 gigabits per second in terms of speed, 10 gigabits, Gbps, which in megabits will be 10,000 megabits per second. Okay, so that's amazing. That is huge to be getting this kind of speed in a wireless network. So that's basically what I want us to cover in terms of the IEEE 802.11 lineups. And also we did mention the regulatory bodies in wireless, as well as defining what a WLAN is, the frequency bands. We have licensed and unlicensed. But then when we're talking about wireless local area network, aka Wi-Fi, we'll be looking at unlicensed frequency bands. So when we're talking about wireless local area network, also known as Wi-Fi, the frequency band used here is called unlicensed. And there are two major bands we'll be talking about, 2.4 and 5. Anytime we talk about Wi-Fi technology or we talk about wireless local area network, 5 gigahertz and 2.4 gigahertz. Okay, so that will be it on the theory. And now it's time for us to jump into the configuration. We want to see how we can set up a wireless network. What I needed to show you. So this is TP-Link website, and this is a Wi-Fi device. This is ceiling mounted. This is wall mounted. These ones are built-in antennas. So you won't see antenna outside. This is also a Wi-Fi device. And as I did say earlier, we have Wi-Fi 7 technology these days, which can go as far as 46 gigabits per second. Wi-Fi 6 is 802.11ax. That is Wi-Fi 7, which goes almost 4 times the speed of Wi-Fi 6. This is TP-Link. They are not the only one that make Wi-Fi equipment. There is Linksys, there is Netgear, there is D-Link, there is Cisco, a host of other vendors. But it just appeared that this is the one I'll be using in the demo. And once you have understood what we are going to show you in demo here, then you should be able to set up any Wi-Fi router regardless of who the vendor is. Vendor, once again, is TP-Link that we are going to use. Now, what are the default settings of this device? Default settings, because those default settings will help us to see how we can connect to the device and configure it. I can assure you this is very straightforward. You only see it here on the whiteboard, on the demo, and I can bet you should be able to log into your own that you have in your home and look at the settings that we are configured in it. So first off, it comes with an IP address. What is the IP? 192.168.0.1. This particular one I have. So you might have other ones that come with 192.168.1.1. It might not be 0.1, it could be 1.1. 255.255.0. So this TP-Link comes with this IP from the factory. I wasn't the one that gave it. As I bought it, I have to unbox it from the box, and the IP was written at the bottom of it. At the bottom, if I turn this antenna upside down, I will see the IP written on the body. But apart from seeing the IP written on the body, there is another information it comes with. It comes with a username and it comes with a password. So these are the default settings of this device. A username is admin and a password is admin. Now, best practice suggests that when you log into the device for the first time, you could still leave the username of admin, or probably you might have to change it. So you might change it to something that is no longer admin for security, to prevent people from hacking into your home Wi-Fi router. And you also need to change the password from admin to something else. And I believe that the ISP that installed your home router for you in your home must have done the needful by changing this default credential to something else. Otherwise, if it's still admin, you should be able to use it and log into the device. All right. Now, what we are going to do, this particular TP-Link has 5 ports. There is one port here that is labeled Internet. Is separated from the rest of the other ports, and there are 4 ports here that are together: port 1, port 2, port 3, and port 4. So they are labeled 1, 2, 3, 4. Connecting to this device for the first time, we have not set up a Wi-Fi on it yet, so I've got to need a cable. So currently I have a second laptop that is connected to this TP-Link with a network cable, precisely Cat6 cable. So there is a cable connecting this PC to one of the 4 ports that are together. Don't use the internet port. The internet port is to use to connect us to the ISP so that the internet can come into the home Wi-Fi router. So we're not using it, it's for ISP. The one we are using is the 4 ports that are close to each other. However, some of these devices will come with just a single LAN port. So it's not a must that all of them should have 4 ports. So the ones that have 4 ports like this is actually a router. We'll call it Wi-Fi router. But the ones that have just a single port, they are called access points, or WAP, wireless access points. Okay, the Wi-Fi router comes with 0.1. We can give this PC here 0.2. So we're going to configure it with 192.168. Whatever is next after the .1. So the router is already .1, and we cannot give this PC .1 again. There will be a conflict. So we have to give it either .2 or any number of our choice between 2 and 254. So once we have given this PC its own IP address, and of course, this is a Class C network, so we are going to follow it up with a Class C subnet mask 255.255.255.0. The next thing to do is to go to our web browser, open a web browser, and on the address bar, where you normally type www.facebook.com, we are not going to type Facebook, but this time we'll be putting the IP of the Wi-Fi device, which in this case will be 192.168.0.1. So I think you'll understand this better if I'm showing you real time.
Yes.
So I'm going to connect to the other PC. So on this PC has got a cable connecting it to the Wi-Fi device. You could see the Wi-Fi device is TP-Link 3G, 4G router. Okay, so on this Wi-Fi device, having connected my laptop to it, I've also ensured that my laptop was given an IP address. What IP address? 192.168.0.2. Recall that the Wi-Fi device came with 192.168.0.1 from the manufacturer. So I've used a Cat6 cable to connect my laptop to the Wi-Fi router. And now that a laptop is connected to the Wi-Fi router and an IP address has been given to my laptop, which is 0.2, time has come for us to open a web browser. So here I've already opened Google Chrome, and on the address bar, I have to type 192.168.0.1, which is whose IP? The IP of your Wi-Fi router. The IP came with from the manufacturer. So once I put that IP on a browser and hit the enter key on the keyboard, the web page opens. The device is asking you to put in a username and to put in a password. How do we know the password? Recall that I did mention that these devices come with password settings and also usernames. So it comes with a username of admin and it comes with a username of password. This once again is written at the bottom of that device. When you turn the other way of the device, you are going to see the IP address that it came with. You are going to see the username and password that it came with. So since this is written on the body, it wouldn't be an issue figuring it out. And once we have figured it out, we are going to head over to the browser and enter it here. So here the username should be admin, which is the default setting that came with the device. And the password again should also be admin. At this point, you have to hit the login button and it takes us into the device. So I'm inside the Wi-Fi router I have at home here. And basically, we can actually go ahead and set up the Wi-Fi. So here we have quick setup. Quick setup is for novice, people that don't really know what they are doing, and so they just want to rely on the device to set the device up for them. So if you want to use quick setup, then you can go ahead and click on next, and the device will be telling you what to put. But I want us to set it up as a pro. So we can either go to basic setting, where we can see the internet connection setup, and we also see the wireless setup. But I want us to see that internet is showing me red X, which means that I've not connected that internet port to an ISP. So let's go to advanced settings. So this way I want you to be familiar with. So here you can see the IP that the device came with, 192.168.0.1. But what we are coming here to do is to set up a Wi-Fi device. So you can see this particular device operating 2.4 gigahertz, which means that the speed will not be that much, but it will cover longer distance compared to 5 gigahertz equipment that the speed will be high, but it's to cover shorter distance. So just logging into the device, this tells us that this one is operating in what? 2.4 gigahertz frequency band. So we click on that wireless 2.4 gigahertz, and here we can see wireless settings. So we go to wireless settings so that I can set up a wireless. This is where you put the name of the wireless. So if I click on a Wi-Fi in my area, so you could see that I have a couple of Wi-Fi here, and I have a Wi-Fi called TP-Link FD5E, and that's actually is this guy. So the name you want to give to your network that you'll be seeing from your other devices is what you put in here. So you can see this TP-Link 5D-FE is being seen by my laptop Wi-Fi. And that actually means that we can actually change the name of this network. By the way, this name of the network is also called SSID. You see SSID somewhere here, which stands for Service Set Identifier. Service Set Identifier is the name of a wireless network. If you do not give this wireless network a name, then it will be difficult for us to locate it on our laptops or on our mobile phones. If I turn on the Wi-Fi on my phone, I should still see a network called TP-Link 5D-FE. Let's change this name just for the fun of it. So we are going to put it to Fiber Train Wi-Fi. All right. So here we are going to specify the wireless network mode. The wireless network mode for 2.4, because you notice that our Wi-Fi is operating in 2.4 gigahertz. 2.4 gigahertz frequency band actually have a total of 14 channels. So if I drop down here, you are going to see, okay, the channel is on auto. But if I drop down, you see that we have channel 1, channel 2, channel 3, channel 4, channel 5, and we're going to have a total of 14. Okay, so we're actually seeing 13 here, but 2.4 gigahertz has 14 channels. Now, what do we mean by these channels? The frequency band, which is 2.4 gigahertz, will be divided into smaller chunks called channels. And so why do I need to explain this channel? Because understanding channels will help you to know how to set up your Wi-Fi correctly, so that once your Wi-Fi is set up in a very professional way, you're going to have a very strong signal. So what I want to point out here is the channels you should always use is channel 1, channel 6, and channel 11. Those are called clean channels. And so these channel 1, 6, and 11 are the clean channels, meaning channels that do not cause wireless interference. So there is actually a tool. You can download Wi-Fi Scanner. And what does Wi-Fi Scanner do? Wi-Fi Scanner helps us to scan our environment, and we'll be able to see the channels that our neighbors' Wi-Fi are operating on. So you probably have a couple of neighbors flagging you, and these your neighbors also have their own home Wi-Fi router, and wireless is already set up on them. If your neighbor's Wi-Fi is on 6, meaning channel 6, if you put your own Wi-Fi on the same channel 6, your Wi-Fi will have a very poor signal. So you have to ensure that, we only have 3 channels, 1, 6, and 11. If everyone in your neighborhood is on channel 1 and 6, then make sure that you set your own Wi-Fi router channel to be on 11. Don't be on the same channel as your neighbor so that you don't have wireless interference. That's actually why I explained this channel here. But you notice that when I came in here, it was on auto. Okay, so auto simply means that this Wi-Fi router, TP-Link, has the ability to do wireless scanning and detect what channels my neighbor Wi-Fi's are, and it's going to put me on a channel that nobody is on. So let's say it automatically does the scanning on our behalf, and it detects that within my neighborhood, majority of the Wi-Fi there are operating on channel 1 and on channel 6, is going to switch me to channel 11. That's what the auto does. But you can
how you can see it, like for example, if I don't have the auto and I am setting up mine, but I don't know which channel my neighbor are. How can you see it? Like if my neighbor, they are in 6 or in 1 or 6 or 11.
Okay, so so to get to know what your neighbor is using, you've got to download Wi-Fi Scanner. Okay, so this is what Wi-Fi Scanner looks like. So we just downloaded one for free. This particular one we downloaded, I only have 10 days to use it. So it's a free trial, but it will just do what we want to do. So I just launched it, and you could see all the Wi-Fi in my area. So I have FBI secured, I have Fiber Train Limited, and I have TP-Link. So this first 3 Wi-Fi is mine. So now I have other ones within my neighborhood: Techno Pop, Spectra, Techno Camon, Red Cheetah. These are basically the Wi-Fi I have within my neighborhood, and it tells you the vendor that manufacture the Wi-Fi equipment. So you could see here is TP-Link Technologies, and we have a couple of them made by Cambium. We also have a Wi-Fi device here running on Ubiquiti network equipment. All right, so what made us to come here is actually to see what channel these Wi-Fi's are operating on. See, let's even look at the TP-Link. The TP-Link,
Okay.
which we are configuring.
Yeah.
I'm going to scroll down to the right-hand side. So you can see that TP-Link is operating in 802.11b, G, and N.
Yeah.
And the speed is 300 megabits per second.
Okay.
It's operating in 2.4 gigahertz. That is the frequency band.
Yeah.
But what about the what are we even looking for? We are looking for the channel, right?
The channel, yeah, like
So
what they use, like
yeah, I want to know if it's on channel 1, channel 6,
channel.
etc.
Oh, okay. No, that's it.
So you can see channel here.
Yeah.
They say my own is on channel 11.
Yeah.
And we have another one, channel 11. There's another one, channel 13, channel 6, channel 6, channel 6, channel 6. So it probably means that I will have to put my Wi-Fi on channel 1.
Okay.
You see the channels for different Wi-Fi I have?
Yeah.
So if I scroll to this side, you see this one here, St. Timothy PTP. If we scroll here, we could see that St. Timothy Wi-Fi is on channel 2.
Yeah, but that's not a good channel, right?
It's not a good channel.
You say the best is, the best is you say 1, 6, or 11, right?
Yes. So you could see here that the 211 that I have here are both my own. This and this are both mine. Both of them are on channel 11. I'm the only one using channel 11 in my neighborhood.
Yeah.
So
because you know better.
Yeah. So I can actually power off one. I'm using 2 of them. One, actually, my mobile phone connected to this one, and this is the one I'm using for the recording. It's more robust than this. So that's how to find it. So you just have to have the tool to scan, and you'll be able to see everything in your neighborhood.
Okay.
Yeah. So you'll also be able to further analyze them and see which one is secured and which one is not that secured. So
yeah,
a whole lot
where
of
can
things.
you see the secure? Here, right? In there.
Yeah, so you can see if I can add more windows. So if I go to properties, here we can see the security here. So this guy is using WPA2 authentication, WPA2 PSK. All right. So I think that I didn't cover this when we're on the whiteboard, but you can see that this Wi-Fi is using a secure authentication. So look at WPA support is not enabled, but you see that security is WPA2.
What that means?
So
that's really good.
Yeah. So what that means, we basically have WPA, we have WPA version 2, and we have WPA version 3. And this guy that I'm putting number 4 is no longer in use, is the weakest. So this is Wi-Fi, wired equivalent privacy. Wired equivalent privacy is not secure. Don't use it. Okay. Security here is vulnerable. So WPA actually means Wi-Fi protected access. So when we did discuss the regulatory bodies in wireless, we mentioned the International Telecommunication Union, we mentioned the Federal Communication Commission, we mentioned the IEEE, and we also mentioned Wi-Fi Alliance. So what Wi-Fi Alliance does is to test the wireless equipment manufactured by different vendors like TP-Link. The Wi-Fi Alliance, what they do is test Wi-Fi equipment manufactured by Wi-Fi vendors like TP-Link, Netgear, and all that, and ensure that those equipment meet compliance before they allow the vendors to begin to ship them. So that's the function of Wi-Fi Alliance. But Wi-Fi Alliance also help us to create Wi-Fi security programs. So we have Wi-Fi protected access. That is WPA. But Wi-Fi protected access version 2 is stronger than this one. So this version 2 is better than this. While Wi-Fi protected access version 3 is better than version 2. Now, when we go back to the scan again, you can see that this particular network, FBI secured, is using Wi-Fi protected access version 2, which is stronger than version 1. Right?
Yes.
Okay. So when we are talking about this Wi-Fi protected access, they all have different flavors. So we have Wi-Fi protected access personal, and we have enterprise. So we always have them in 2 varieties, personal and enterprise. So the Wi-Fi protected access version 2 also has personal, which is also referred to as pre-share key or PSK. And it has enterprise. In enterprise, we're required to have a server. If we don't have a server, we can't use enterprise. So enterprise is mostly used in production in companies that already have server. And so we can set up radios. A server called radios will be used to authenticate Wi-Fi access. And so if you're using enterprise, it means that when people click on our Wi-Fi to connect to it, they will be required to enter username and password. But when we're using personal, which is also known as PSK, pre-share key, we only use password to secure the Wi-Fi. Only password is required to secure the Wi-Fi. If we are using WPA personal, WPA2 personal, or WPA3 personal, then we'll be using only password to secure the Wi-Fi. If we're using WPA enterprise, WPA2 enterprise, and WPA3 enterprise, then we'll be using radios. We'll be using it in a production environment where they already have a server set up. So if you don't have a server, you cannot use enterprise. WEP web, wired equivalent privacy, is the most insecure out of all of these ones listed here. So Wi-Fi 6 devices, all the newer wireless equipment supports WPA3. The Wi-Fi I have that I'm using in this demo doesn't support WPA3. It only supports WPA and WPA2. In that case, where you have only WPA and WPA2, always go for WPA2. Except you have WPA3 support, then you should go for this because this is the strongest in terms of security. So we can get back to the Wi-Fi device. And while I left here, we'll also show you the Wi-Fi scanner that can help you to see what channels your neighbor's Wi-Fi are on, so that you can put it on a channel that is not overloaded, not to have interference in your Wi-Fi. So we've already seen how to use the scanner. And so we can come back here and you notice that majority of my neighbors are on channel 6 as well as channel 1. So I can go ahead and select channel 11. And this particular Wi-Fi router that I have here supports the IEEE 802.11b, 802.11g, and 802.11n. This particular device doesn't support 11a, but it supports 11b, g, and n. And it doesn't support 11ac and 11ax, which are the latest standard for Wi-Fi 6. But the ones it supported will be sufficient for us to set up this Wi-Fi. So first thing first, you put the name of the Wi-Fi. And secondly, we make sure that the Wi-Fi is on a channel that your neighbor's Wi-Fi is not on. And you can get to find out what channel your neighbor is using by scanning the Wi-Fi with a Wi-Fi scanner. We want to also ensure that Wi-Fi router radio is enabled so that you can be able to broadcast this wireless signal so that our devices on the network can see it and connect to it. Enable SSID broadcast should also be ticked, and also click on save. I've actually stayed a long time without doing anything, so the device has timed me out.
Oh, sorry.
So I have to log in back. Okay, so we have to go to advanced settings, and once again, Wi-Fi settings. Once again, we change this to fiber train Wi-Fi. And we'll put the channel to channel 11, as we were saying before.
Mm-hmm.
And now that we have got everything spot on, we have put the Wi-Fi name, and we have also entered the channel, which is 11, because majority of my neighbors are on channel 6 and 1. We'll go ahead and click on save. So the moment we save, the browser is going to refresh. And once that is done, if I come back here to my Wi-Fi adapter on my laptop and click on it, you see the name of the Wi-Fi before was TP-Link FD5E, but you can also see here fibertrain_Wi-Fi. Mm-hmm. So it's just a matter of minutes. This one will disappear. And the only Wi-Fi we should have is this, which is the new Wi-Fi we have set up, fibertrain Wi-Fi. So this Wi-Fi, we just set it up by going to advanced settings and going to wireless 2.4 gigahertz. We drop down, we see wireless settings. That's how we got it. Now, we have to password it. And here you see wireless security. So if I click on wireless security, you're going to see that we have WPA/WPA2 personal. And we have WPA/WPA version 2 enterprise. We also have web. All those things I showed you on the whiteboard, they are here. Mm-hmm. Always note that you never use web. This is the most vulnerable Wi-Fi security program. And always use WPA2. If your device doesn't support WPA3, use WPA2. And the WPA2, we cannot use enterprise. So if I select this enterprise, and here it is asking me for radio server IP address. So we have to put the IP address of your server here. But we don't have a server, and we don't need to acquire a server. They are expensive. We don't need them to secure our home Wi-Fi. That would be a waste of resources. And so what we should be using in a home Wi-Fi security should just be the WPA personal, which is also known as PSK. Okay, so we are selecting that instead of selecting the enterprise. And version of WPA, drop down, you will see WPA and WPA2. WPA PSK, which is pre-share key, is the same thing as WPA personal. And we know that WPA2 is stronger than WPA, so we're going to select 2. Encryption will be advanced encryption standard. We have TKIP, which stands for temporal key integrity protocol. Advanced encryption standard, AES, is stronger than TKIP. So we're going to use advanced encryption standard. Why are we doing encryption? We are doing encryption so that whatever we put here as the Wi-Fi password should be encrypted. So if somebody is trying to hack into our Wi-Fi, if they eventually get the Wi-Fi password, they will not be able to see what the password is because it will be gibberish. It will be encrypted. So they will still need to look for another tool to decrypt it to see the password. And that's why we are using AES to ensure that whatever we put in this box as password is heavily encrypted. So here I'm going to put, what can I use as password? Let me use something generic. So I'll just use ABC at AB. What should I use? ABC at ABC. That's one of the weakest passwords in the world. So the point is, we are using Wi-Fi Protected Access version 2, the personal edition, and we're using advanced encryption standard to ensure that this ABC at ABC is encrypted. So if somebody hack into this Wi-Fi and grab the password, the person will not be able to see this ABC at ABC. The person will have to look for a password cracking tool to decrypt the encryption and be able to see the password. That is another work we are giving to the hacker. In your own Wi-Fi, please ensure that you use uppercase, lowercase, numbers, and special characters in your password. So I'll go ahead and save. All right, so I think this time around is saved. So we have set up a Wi-Fi. Under the wireless 2.4 gigahertz, we went to settings to give the Wi-Fi a name and put it on a specific channel. We go to wireless security here and we select Wi-Fi Protected Access version 2 in order to password the Wi-Fi. So if we go to the wireless adapter on my laptop, we could see that that former name, TP-Link, has disappeared. And what we have now is fibertrain_Wi-Fi, which is exactly what we name the Wi-Fi. And if I'm to click on that Wi-Fi to connect to it, it's going to ask me to provide credentials. And I'll have to know what the credential is, which is this password I put here. I'll have to come here and put exactly that password before the Wi-Fi will allow me to connect. And that's basically how to set up a home Wi-Fi or even a Wi-Fi in a small business environment. So that's actually what we want to cover in today's tutorial. And I do hope that you should be able to replicate this when you go through the video. You should be able to connect your own home router easily.